today, but there's a very high chance that I'm not gonna be able to stream until Friday. Today is Tuesday, I think. So I decided to stream, and I think I'm gonna stream for the remainder of this time here. And what I'm gonna do is just go over the source code. Initially, what I was doing is going over the course again, and I was copying the code while I was uh, watching the course, but then like that was too slow and ineffective. So what I decided to do is just copy the code here, and then I'm gonna try to. There is one problem here. I'm not really sure if there's gonna be more problems, but I'm gonna try to figure out what the problems are, and I'm gonna study the source code and watch the videos off stream. But I think it's gonna come down to just studying the source code. I already have a good idea of the high level concepts and how it works, but I'm gonna have to study the source code. And the thing is that I don't have experience with C, so it's a little bit confusing. And I think that the only way that it's gonna become more clear is if I study the source code and try to build stuff. And the other thing that I realized, I'm gonna try to not focus on all of the other stuff and just focus on the small things that I can do now. So I'm not gonna focus on Python and JavaScript anymore or anything else. I'm just gonna focus on getting this to work with C first, and then building a very simple graph with C with the project that I have here. So the plan is gonna be to modify this project so that I create a graph pretty much just following the structure of the project, like making as little changes as possible and just creating a structure so I can save a graph network of the execution of this on a file. And the other thing that I realized is that it's gonna be a problem because I forgot that the reason why you can pass, like, it's very simple to pass data from Python to JavaScript is because they both have objects and lists and arrays. So you can put the same data structure on the JSON and just pass back and forth. But the problem with C is that is obviously different. So in C you have structs and you have vectors and stuff like that. And I forgot about that. So if I'm gonna save the data structure into a JSON file, I have to see how I'm gonna do it so that I can open this with JavaScript, or if there's another way that I can do it. But the idea that I have is just to separate into three different files, and I'm gonna do that on the other project, not this one. So first I'm just gonna copy all the files that I have on the other one, and I'm formatting them as well to be like this. The way that I like more, I think it looks better. And it's easier for me to understand what's going on. So I'm gonna copy everything, and then I'm gonna go over the course again. I think it's gonna take around 2 other days because I'm going slower this time. And I did a little bit of this thing here, but I'm not really sure if I'm gonna do it much. And it's kind of confusing for me to understand, and then I'm not really sure if it's because it's in C or it's because the way that he did things. So this is something that I have to think about, whether or not it's worth it to try to redo stuff that he did, so it fits more in the way that I think. Because one thing that I'm feeling is that he did like too many functions, and then it gets kind of confusing to understand like the flow of everything. But it might be just because I don't have a lot of experience with C. But the way that it works is you have the main file, then I don't remember exactly the files that it calls, but one file is gonna create a compiler, which is just the file object, and then you're gonna have other files that are responsible for the Lexer and the parsing. And the Lexer is gonna read the file character by character, and each time that it reads, there's a bunch of functions that are gonna add the line and the column of the I don't remember if I think it's not the compiler, it's the Lex process that has a struct which is gonna contain the information for the process. And this is kind of the part that is kind of confusing, because also I think the name he chose is a little bit difficult for me to understand. But it pretty much just reads the file, and then it gets the information file, character by character, and it uses some functions in C to do that. And this is another big difference from C and the other languages, obviously, is that C, you have to think about the memory and the pointers, which is gonna take some time to get used to. But in C, you have a function to get the character, so you pass the file, and you pass another argument, and then that gets the current character, and then based on the current character, he pattern matches based on these cases here. And this define, I think it's a macro that's is part of C, which allows you to just put this stuff here on the code. I don't understand really well how it works. I understand on the surface level, on the concept, but not the specifics of the implementation. And enum is just a list. It works kind of like a list of flag variables, where each one inside of the enum is gonna be like a number, and then you can use this anywhere in the program to do control flow pretty much. So it allows you to have the name instead of putting numbers, which is more descriptive, but it just works as flag variables to determine what's gonna happen on the execution. Then he creates this struct that has information for the token. So it's pretty much just reading the files, character by character, and then creates this token structure out of it. And then from the token structures, later on, it's gonna create a parser and build the abstract syntax tree from the tokens. And then each token is gonna have this, is gonna pass through these cases here to determine what the token does. This is something that I'm gonna have to think about when I'm changing this to work with JavaScript and Python. I think that's the main things that are gonna change, is just the rules of the symbols and how they become this abstract syntax tree, because obviously it's gonna be different. And also I'm gonna have to see, because here he does some stuff to check the type of the variable by just pattern matching the string with the type, but obviously JavaScript and Python don't have that. So I'm gonna have to research on how that's done on JavaScript and Python. But let me remember, there's a confusing part that he, on this file, this is the main file that contains the actual file that is gonna be read. So this is the function, I think, no. Yeah, this is the main function for this file. And it receives the file that you're gonna parse, and then an output file that's gonna be the result of the parsing, I think. I'm not 100% sure what this file contains, the output file, but I know the other one is the one that you wanna parse. In this case, it's task C that he uses. So what I'm thinking about doing is just copying everything, and then I'm gonna try to execute to see if it works first. And then once I get to execute, then I have to start thinking about how I'm gonna implement the graph, which is gonna be harder, I think. A lot harder than in other languages, because I'm probably gonna have to use the library that he creates here for vectors, and I'm gonna have to create a vector of objects, which is gonna be struct in this case. Struct is pretty much, it works in pretty much the same way as an object does in JavaScript and Python. But I'm getting used to the syntax over time. The syntax is not that hard. The hardest part is understanding how to deal with the pointers and the buffer and these libraries he created here, which in the other one there's also more libraries that I have to copy. So this function creates the struct that is going to contain the information for the file, which I think has the position, which has the row and column, and the file object, and the input file object and the output file object. And then in the input file object, there's another information there. I think maybe it's the input file that contains the other information. So it just opens the file. This struct. This one I didn't get to the part where he puts this extra argument here. I'm still on the part of the course that's just these 3 arguments. But this is kind of what I mean, that is kind of confusing because maybe it's because of the names of the variables, but it's also because it's in C that it's hard for me to visualize in my mind like the connection of everything. So process. So it's declaring a process here. The calloc is something that allows you to allocate memory. So you specify the amount of things you want to allocate memory for, and the second number is the value, and initially sets everything to 0. Kloc does that, and malloc or malloc, whatever say that, is very similar to kloc, but it doesn't set everything to 0 initially. So he pretty much allocates memory to this of the size of this struct here. One thing that I didn't like about C is that it's very confusing to understand where everything comes from, because unlike the other languages where you specify the path of which thing is gonna come. So for example, you have like a function on a file like main. You import the function from main, so it's very easy to know where the function is coming from. But here, in the way that this project is, at least, everything is on this compiler H file, so not everything, there's other functions as well that come from standard libraries and things like that. So it's kind of hard to know where the function comes from. The import system is kind of confusing because it's different than the other languages. And the way that it works is just modules. And the reason why I think it works this way, based on what I researched, is that and this is another thing that I'm gonna have to figure out, that I'm still thinking about whether or not to create another project from here and then use this project on the other project. But the thing is that the reason why it works this way is because if you want to compile everything, it would take too long because it's too much code. So every time you run, you would have to compile everything. You would like take a lot of time to run each time, which is not efficient. So what people do is just create the executables, and that's the libraries, and that's the reason why you have the H file, which defines what's gonna have what the executable is gonna have. And there's a program that's called the linker, I think, that links the declaration that you put on the header file with the definition that is on the executable file. And that makes it so that it doesn't take too long because you're accessing the executables already for everything. So you don't have to compile most of the libraries. But it's kind of confusing. I forgot to start running this. So here there's a bunch, maybe a good thing. The main problem this file has is with this library here in the beginning, that I think is for something on Linux, this one, that is giving me a problem here. So I'm gonna have to figure this out. I'm gonna have to pay attention at what part of the course he puts this. The other thing that I had to deal with, and it's not that hard, it's very simple, but I had a problem, which is with the Makefile. The way that the Makefile works is just a file that is going to run everything. So you put everything you want to run here, and then every time you put make on the command line, it's going to run all the commands that you put here. But the issue here is that the way that he did the course, he doesn't on Linux, so the commands are on Linux as well. So I had to change for working on Windows, and the problem is when you change the commands to work on Windows, the path fucks up. So I had to create another variable. The easiest way I found is to create another variable and then just use the other variable to clean everything, because on the cleaning command it doesn't work if you try with this command here, because it's for Linux. So, and this is something that I'm gonna have to figure out here as well. That is kind of also annoying that I have to put everything that every new file that I'm gonna do, I have to put it on here. The other approach that you probably can do instead of creating the other variable is just create some extra logic here that is gonna take, because there is some simple logic you can use on these files in the same way that I believe you can use on the command line that allows you to loop over files and things like that. So I could create some extra logic that checks to see if the commands is acceptable on Windows and whatever, but I don't want to spend time with that. but I have to see which files here that I don't have there. Maybe I just copy everything. I think I'm gonna create another file. So this is what I had to do. So this path's here, and it should backslashes because backslash works as a escape character, so it's better to put 2. But it works with 1 as well. But I prefer to put 2 and it's working. And the way that it works is just you put the labels here. They're always gonna happen when you put make, and it's gonna run everything here. Which is just using GCC, which is a C++, I think, or C compiler that runs calls the file and the output path. This slash O is the output. So it creates these executables at the path that you put here. And then the clean command is to just delete the executables. So usually the way he does is just runs make to see if everything works and then runs clean. So you have to run make, then it creates the executable, then you just call the file on the terminal, and then it executes the binary. And this is something that I'm thinking about, like how I'm gonna do it, because I'm gonna have to create a bunch of other functions to create the graph and to put the graph in JSON. So I'm not really sure if it's better to do that on another folder and then, but I'm gonna have to change the source code anyway, and that's the thing that I'm kind of contemplating what to do. Because what I was thinking is like, how can I just use the project in another project? And one way that I thought about it is just compile everything, get the executable, and then I just use the executable on the other one. So I just put the executable on the make file, and then it runs that executable first, but that doesn't make a lot of sense. So I have to research on how, like, and this is the kind of stuff that is kind of hard to understand in the beginning, which I'm struggling now, which is also when to use each thing. So one example is this arrow operator. In C, you can use the arrow operator to access stuff, and he usually does that when he's accessing elements on the struct. And you can use also the dot operator to access stuff. So it's the same way that it is on other programming languages, where if you want to access the value of an object, you just put the dot operator and access it. But in C, you have to choose the arrow when you're using struct, because you have to dereference the thing. And then sometimes you're going to use the arrow operator, and sometimes you use the dot. And it's very hard to know which time you do each thing. This function here he uses all the time as well, which is just comparing 2 strings to see if they're equal. So you can create this macros here, and then you can call this every time on the across the program, instead of having to do the function. It is kind of like a function, so, but I don't know exactly what the difference is between the macro and the functions. And there's also another function here that I want to show. Yeah, so this is the position of the thing. I think I need to clarify more now this relationship between what he calls compiler. There's the C process, the compiler, and the Lex process, which is the main files here, and then the Lexer, which contains a bunch of functions as well. And then they are related because they all call functions on each other to create the structure of the token. But it's kind of confusing how it works. So I believe this is the function, the main function. That's the input file. The flags also is kind of confusing. I don't understand really well how it works. And this is the main thing that creates the process. So it opens the file, the read file. So this is the input file, the output file. If you put, it's gonna open to write and allocates memory, creates the vector. So it's pretty much just initializing the process. So I have to see. The process is a struct, is this one. I think that's probably the reason why it's kind of confusing, because it's the struct is the same name here, but this is just what the function is going to return, I think. So you put here whatever the function returns. Yeah, that's the case. So when it's void, the function doesn't return anything, and whatever the function is going to return, you have to assign the function with that. So it just returns this struct, which is here. And this is the thing that I was talking about at the beginning. I think that yeah, it holds the position of the thing. So it's kind of like a pointer in the file that's moving character by character and line by line. And it accepts the input file and the output file, and then the vectors here, with the information from the token. Some of these I didn't go over with the course again. I think I stopped at this point here where he adds this true here. This is gonna be the vector that holds the entire abstract syntax tree, and this is gonna be the vector that holds the current tokens that are being processed. So I think it works kind of like a stack where it reads the file, then pushes tokens into the stack, and then analyzes them, and then pops them out. That's how it works. And I think that's how you create the expressions. And the scope is kind of confusing as well, but I think it works. The scope, at least it felt like to me, that it works kind of like a linked list, where each scope only has its parent. So it has its own location and the location of the parent. And then to find other scopes, you just navigate from one parent to the other. But it's kind of confusing. I didn't like that much the way he explained, because I didn't understand really well. So maybe I'll have to go back to understand that again. And I think that, like I said, like one of the biggest reasons probably why it's confusing for me is because I don't have a lot of experience in C. I understand the code, but I don't have experience programming, so my mind is used to doing things on Python or JavaScript, and it's not very different, but it is different. So, and symbols is the things that he uses to get the signature of each thing, I think. So when you declare a variable, the variable is a symbol, and every symbol is unique. So you can't have two different things that have the same name. So if you have a struct called scope, you can't have a function called scope, I think. And each one has their own symbol, and that's the point of the tables. So it creates a table to map the symbol with the thing. And that's on the parser part. So let me say here. I'm just gonna talk about this stuff because it's gonna help me clarify in my mind how it works. I remember I spent the reason why I did this was because at the beginning, when I was doing everything manually, it was kind of confusing for me to understand. So I'm gonna try to follow the path again to remember. So let me think. So this creates the process, and the process is this struct here that has the information of everything that's gonna happen, I think. So the compile process is the main thing that holds the objects and the position and the flags. And then it's gonna hold the vector and the syntax tree as well. So it's kind of like an object that moves like a pointer, where at each character is gonna change the data inside of this, I think. So I have this process. Let's see. Yeah, it initializes everything with this vector create comes from the other library, which is the helpers vector that he created. The flags. I didn't get to the resolver part again. I don't remember really well what the resolver is for. Yeah, I don't remember. I should say. Yeah, it's for the symbols probably. I think I stopped very close to this part. I'm trying to find the balance of not going too slow but not going too fast, but it's very hard. C file is the input file. So it pretty much just initializes the struct with all the information in the beginning. So it's going to be empty vectors here, and the other ones are going to be whatever they are, either structs or numbers. So that's what this function does. I didn't get to this part still. Real path probably comes from the standard libraries, so maybe it's better to write this down. This is another thing I don't like really well, which reminds me of TypeScript. But maybe it's the way that I'm thinking that is not very good. It's hard to tell. But the feeling that I have is that it doesn't make a lot of sense to go to the function definition. I think the way that it works like this on C is because of the stuff that I explained. That because you have to compile everything to binary, you're not gonna have access to the function definition, because the function definition only exists on the binary code. And that's the reason why it goes to the declaration file. But the problem with that is that it doesn't tell you much. I think that's the feeling that I have, but maybe I'm wrong. Like when you go to the function definition, it doesn't allow you to understand what is going on with the function. So it's kind of useless. It's the same, it's just having the name there. So after it creates this process, this is the part that is going to start reading the characters. So the Lex process is the stuff that reads the files, and then it's going to create the Lexers, the Lex tokens. So it presses the process, and this is the part that is kind of confusing, because this has a function. It's a struct that maps names to functions, and the functions are going to be like helper functions to look into the file. So we have three functions. One is to pick the file, pick character, the other one is next character, and the other one is push character. The pick character allows you to see the character. The next character allows you to see the character and then move to the next one, I think. And the push character, I don't remember really well what it does, but I think it just gets the character again from the file. And it's kind of confusing because it's in C, so the functions are from standard library in C, and it's based on memory, because when you use a variable in C for a function, you lose the variable in memory. So if you pass the function as an argument here, then the main program is not going to have the variable anymore because the variable was used. So you can either do it like he's doing here, where you pass the reference of the variable, not the variable itself, and then you're still going to have access outside. But if you pass the variable itself, you lose access. So you have two different functions that pretty much, one allows you to get the character and one allows you to unget the character. But I have to watch the videos again to remember, to solidify in my mind how it works. Yeah, but it's pretty much this struct in the beginning here. And then this functions comes from the C process, maybe? I don't remember which file. Yeah, C process. And this is the stuff that I was talking about, where it's accessing the value of the C file. So that comes from the main struct there, from the process. I guess this is kind of why it's confusing, because you have the Lex process, which is struct that has a compiler, and the compiler is going to be the other struct that I was just looking at, I think. And that's the thing that is kind of confusing. So the Lex process, I think, is the main thing, and the compiler is the instance inside of the Lex process that is going to hold the information of what's happening. But it is kind of confusing. So the compile process has the files, the information for what's happening as you read, and the Lex process contains a compiler, an instance of a compiler process, which the Lex process also has the position, the token vector, and this is the compiler instance. So it's pretty much a nested object, and I think the Lex process is the main thing that creates the Lexer, the Lex tokens. So it has the compiler inside of it, the parenthesis buffer is a buffer that he creates to parse the stuff inside of expressions. So whenever you have a opening parenthesis, we're gonna have an expression, and that's a pattern he matches. And the other one, the closing parenthesis, is a symbol and not an expression thing. The reason why they're different, I don't remember, he talks about, but I don't remember really well. But it's pretty much because the opening one, it starts the expression, and the other one, it doesn't, it just ends. So there's a difference in the way that the compiler views them. It's probably just because of the way that you parse, obviously. So the way that you create the tokens and the parsing, just from left to right. So the opening one is the one that matters. So it opens the expression, and inside of the expression it has some logic to determine which one is going to be. It creates an operator tree out of whatever happens here, and then a part that is confusing that I'm probably going to have to review again. That's, he says that he creates some functions to shift the expression to the left based on the order of precedence. Which is, in JavaScript is this one, he shows the one for C, obviously. So this determines which operator should come first or last, and the tree is obviously created based on that. So I think that what the function does is just shifts the tokens inside of the tree based on the order of precedence here, which is done with pattern matching. So the concept is not very hard to understand. The hardest part is the understanding on C how to do it, like how the nuances of how he does it. And this private, I don't understand really well what's the point. So let me go back here. And so you get the current compiler that the Lexer process has, then you increase the column, which is you're just going to the right. Then you get, this function gets the character, and you pass in the file instance. The C file is the input file, and the FP I think is the file, because this C file is a struct that contains the position, I think. Don't remember really well, I have to see there. But I remember there's two, when I stopped there was two things here. Yeah, so one, where is this? Maybe it's on the Lexer process thing. I remember there is a struct that has two different values. It's the compiler. C file. Yeah, this is the input file. Yeah, C file. It is the absolute path and the file. But this is the pointer for the file object. Not really sure what the absolute path is though, if it is the position. It's accessing FB, which is the file object. So just passing the file object to this function, and this function gets the character. One thing that I don't understand really well is how is it possible to get in the correct character. I don't understand this. I think it's probably the reason why is probably because the way that he reads the file is with a buffer. So the way that the buffer works is like a small space in memory where you put data. So it's like the buffer receives a string of data and then outputs, and then it's like a small window between the input and output. And I think that function is going to read whatever is at the current pointer in the buffer, like the current position. But I don't understand really well how it works. So I have to review this function, I think. Like, this is what I mean, is the conceptual level is easy to understand, just reading the character. And then here it checks to see if it's a new line. If it is a new line, it just increases the line. And makes the column equal to 1, because that's the beginning of the other line. But it's hard to understand what is happening on the buffer here, I think. Like how is it possible that it's reading the correct character here? Yeah. think the only explanation is probably has to do with the buffer that the file object uses. So the file object itself is a buffer. And I think that's how it works. Maybe I should go back to the operational system course as well to remember. Because, yeah, it's definitely like that. Now I remember. Because the file is stored on disk and then use the buffer to go back and forth between the disk and the RAM, I think. Yeah, this is the standard he uses on the operational system one, which determines the metadata that's gonna be the file, so where the file is gonna stay. So this communicates with the hard disk, and then you encode the information here of what's gonna happen in the operational system, I think. Based on the file standard, you code the instructions that create the modes of the file. So if you pass the R, it's gonna be read. If you pass the W, it's gonna be write. Depending which mode it is, it's gonna determine how the buffer communicates with the system to read the memory. So I think that the reason why the getC works is just because of the nature of the buffer that the file stream object is. And this one, it just looks at the character. And then this is the thing that is also kind of confusing, because this is the function that ungets. So I assume that when you do this one, it reads the data for the current points in the buffer for the character. So you kind of like lose the character because you just used it. And then this function allows you to put that character again in the same spot in the buffer from the file object. So it's kind of like you're placing it back. Imagine like you have a shelf, and then you're getting a book. That's the getC. You get the book, but then the book is not on the shelf anymore. So in the other parts of the program, if the other thing that is going to look at the book is going to look at the next book, not the one that you want. So to unget, to put the book back on the shelf, you have to use the ungetC. So this allows you to just look at the character, but not move on, but not lose it. And I think this one you just remove, and then you go to the next one based on these positions here, these calculations. And the push char is just removing. And I think this is confusing because the name is push, but it just removes from the file, so I don't understand really well. I guess it just means push because you're pushing out of the file and into the stack, maybe. I have to see where this function is used. Yeah, so it passes these functions, and I think that this is gonna attach the process with these functions here. So the process is always also a struct. Comes from here. So I think this, yeah, this is the compile process, which is this thing here, which has the information for everything. So this is the process here, and then it passes this to this Lexer, and then it's going to create the other struct that contains the compiler inside of it with the functions. I'm pretty sure that's how it works. I think this is on here. Yeah, this is the compiler. And it's just attaching, the process is going to be the Lex struct, which has the overall information. So I think it's getting clear in my mind now. It works. But it is kind of confusing because of you have the Lex process and then you have the compiler, and they both have different positions. So it's kind of confusing to know. So I have to understand why it creates this position here. Maybe I'll have to go back on the course. I'm trying to go faster because I don't want to take a bunch of time, because I have to build stuff, so. But obviously, if I go too fast, then it's pointless as well. And this is the main thing, I think, for the Lexer parts. No, this is probably the main. This just creates the thing, the structure, and this is the thing that is gonna create the tokens. Or maybe not. Maybe I'm confusing myself. No, this, yeah, it creates the tokens here. So it creates the process, then it creates the tokens based on this process, which is the struct, which contains the information. So this is gonna have the other functions. And this is just the lexing part, then the parsing comes here, the code generator I'm thinking about getting from the other project. But I think before I do the code generation, and I focus on the other parts, I'm gonna try to build the graph from this stuff first, and just get the information sequentially. So as it is creating the tokens here, I'm going to append to create a graph, and then I'm probably gonna create a node struct and edge struct, and then I'm gonna use the vector library so I can create other functions here in the same way he did there, that creates a vector that contains, there's gonna contain the nodes, and a vector that is gonna contain the edges, and that's gonna be the graph. And then inside of the struct, I just put the information that I put on the other project, and then as it's going over the functions, I create the edges and nodes, and then after I have that, then I can figure out how to put it on a JSON file. So this is and I'm gonna forget about the other stuff so I don't get into paralysis by analysis. Token back is the current token for the Lexer, I think. Maybe it's this function that creates. So this is the function that creates the tokens, probably. It passes the process. Let's see what's position. Just says line, column, and file name. Oh, the other, I need to find the other thing that I think is clever, the way that he did it. But it was a little bit confusing to understand. Not confusing, I think it's the first time that I did the course, I just was going very fast, so I didn't pay attention. Then the previous one, like, I understood the concept, but I didn't pay attention on how exactly what's going on. The first time I just watched very fast to understand like the general picture. And the hardest part is not understanding the code, I think. It's because I have so many things in my mind about all the other stuff that I have to do, like the overall general picture of how everything's gonna come together. That makes it hard because it makes it very confusing. So it's hard to strike the balance between focusing on the stuff that I want to do right now and the overall general picture. The names, I'm gonna have to create a different name for the node. Probably gonna put graph node, something like that. A union as well that I didn't know before is just a way, something that allows you to share memory between things. Like every time, at least from what I understand right now, every time you put a bunch of stuff inside of a union, it's supposed to only one value is gonna exist at a time. So you're saying to the not saying to the memory, not quite sure. You're allocating a fixed amount of memory for these things here, and then at each given point in time, one of these things is gonna occupy the space. If that makes sense. But every time that I look into this, it gets easier to understand. So it's probably not gonna take a lot of time. No, the hard part comes later. It's creating everything else. Where is this stuff? Maybe I missed it. Or maybe it should be on this file. There's something with the definition. Something to get the expression. He created a macro that he puts it's a for loop, and then inside of the for loop he puts a condition of when the for loop is gonna run. And that allows him to put to pattern match inside of the condition on the for loop. So it's like a for loop in JavaScript where I have I like that, and then you have a condition here. And then you increase. And then this condition on the macro becomes whatever he passes to the macro. So based on this condition, he passes a pattern match at the string, and that decides whether or not the next characters are gonna be of that string pattern, which allows him to capture the pattern that he wants. But I forgot where he puts this stuff here. Yeah, maybe it's this thing here. Or maybe it's on another file, or maybe he changes later on. Because now just copied everything into this file, or the final thing. Format before was following along, so maybe it's different. Maybe he changes at some point and it removes that thing. Maybe now I should see if I can make the Makefile. I think I'm gonna copy. What would be an easy way? 'Cause I don't know. I have to redo like this. I think I'm just gonna copy the code here, and then I'm just gonna change the cling. It's probably easier. Oh, actually, I have to save these commands here. I don't want to think about this again. So maybe I'll just copy I'll copy this part. So the other thing that I have to review is I think the biggest things is the module system that is different, very different from Python and JavaScript. I'm not used at all to think like this and to do things like with this Makefile. And the other stuff is the memory and the buffer. buffer and vectors. And then I have to search how to write, because obviously one thing that I can do is just put the pattern that I want to write, but then it's more complicated and annoying. So like I don't need to just dump or just see how to dump the vector that is going to contain the structs inside of the JSON. And I think if I try to do that, it's probably not going to work because it's going to be a different data structure. Even if I can write, the problem is that I'm not going to be able to read in Python unless I can find the library or something. But another thing I can do is just construct as if I'm writing a string. So I put the symbols together based on the data structure that I have instead. But that sounds like a lot more work. So now I have to see everything that I put. Actually, it's kind of easier to just... let me see. So here I have clean objects. Yeah, it's easier to just copy there and just change the things. Change the slice, or however you say this, or put the backslash. I'm gonna do this later. The first thing that I want to do is, like I said, copy everything and then just try to run with the Makefile, with the make command. The other thing that he uses is gdb, and then he calls the name of the file, which is a debugger that uses GCC, I think, or something like that. And that allows you to step over the code. But I'm not really sure if I'm going to use that. I think I'm just going to try to run. Then after I run, I have to research on how to... I have to think about what is the best way. Probably what I'm going to do is just change the code here and try to incorporate the stuff that I add. And then try to run at each time. After each time that I do like a small change, try to run. And I'm probably going to have to add... I think he adds all the files that he has on the project to run here. So this is something that I have to, maybe have to research again. I think that the order matters here. So I have to think about where to put this. Because I'm probably going to create other files. So it's probably going to come before everything, because I want to create the graph first. At the graph structure. Then run everything else. So let me go back to the... I want to try to find, see if I can find the functions that are gonna... Where are the functions that actually read the characters and do everything. I think it's this one. So this one creates the structs, so you pass the struct here. And these are flags just to see if everything worked fine or not. So I think I'm gonna just run with a normal C file first. Once I get to the point that I have the graph, then what I'm gonna do, like the graph in JSON format, I'm just gonna transfer the file into the other project and see how it looks. And then from that point, it's just like optimizing that, I think. But then I have to think about like what direction is better to go. If I should just optimize first on the creation of a graph in C because it's gonna be easier, or if I should start researching how to change this. Because probably the best way, maybe I should copy this. Like after I fix everything, I should copy into another folder to save like as a... to save for later, because probably what's the best thing to do is just to... Before adding the logic to the graph, is just change whatever is necessary to parse other types of files. That's probably the best thing to do, because there's only going to be like the main bulk of the things I think are already here. So the differences are gonna be just nuances on the syntax, the way that it works. So, and the idea that I have is just to add these differences so I can parse Python, JavaScript, and C. Then once I have that, then I can construct the graphs. But I'm not really sure if it's better to just try to do it on another language instead after I make it work with C, because it's gonna be a lot easier to develop, I think. So, yeah, a lot of stuff to think about. Here passes the process. So this absolute path is just the name of the file. It's where the file is located, I think. So one is the file object, the other is the name. And then here it makes the name of the process. The main of the file name in the position of the process should be equal to the path of the file, and then probably this function is the one that's, yeah, this is initializes and then it's gonna go over all the file things. So this is the main function. And then here it has, this is the stuff that I mean, that the conceptual level is very easy to understand. It's just going over character by character and then pattern matching based on the switch, and then for each thing it calls it the specific function to handle that case. So I have to clarify the buffer. Maybe I'll watch the operational system again, the courses about the file structures. Yeah, so this is the main function. So probably inside of each of these functions, I have to think what's the best design. But it's actually not that hard to understand. It's just in the beginning, it's overwhelming because there's a bunch of things, but then if you spend some time, it becomes a lot easier. It's not that hard, actually.
The mystery of life isn't a problem to solve.
I think the way that he structured everything is probably very good. It's just that it felt confusing to me because I don't understand C very well. So there's a bunch of stuff that is... It's not that I knew the syntax, but it's new because I don't have experience thinking about it in that way. So it feels more confusing than it actually is. Because it's additional stuff that you have to think about, like this, which type of character, which type of data structure you're gonna use. This one, I think it comes from C as well, so I'm gonna research this. So one option would be to, yeah, it's probably gonna be better to do it. I think it's gonna be better to do the graph on the switch statement. So after it gets the token, because what I want is the token already finished, and all these functions are gonna be just for each case it's gonna run each specific thing to get the characters. And this is the macro that I was talking about. So he passes a buffer, then passes the character, and this is the expression that is gonna be the condition inside of the loop. And then based on the condition, it's gonna loop over the characters and put them on the buffer. So C, this peak C is from the Lex process. No, it's from the C process, which is going to be this function here, which was kind of confusing for me in the beginning because of the names. But this function is assigned on the struct there somewhere, I think on this here, yeah, this here. So there's a sign on here, so it's kind of mapping. And then he puts this thing here inside of the Lex process, which is a struct, which is going to contain the process, which is also a struct. So this contains the file and the information for the what's going to be read, and then this contains the information for creating the token. So the compiler is kind of like the pointer going over the file that holds the information for each character, I think. And the Lex process is the struct that contains the information for the actual token, I think. So yeah, it makes a lot of sense. And then these are the functions that are going to allow you to do whatever you want to do with the current character. So if you want to move to the next one, or get, or push. So let me see if I can... Oh, so it is defined here, that's why I wasn't finding on the other one. Yeah, so the expression is the thing that are going to pass, a condition, and then it's just a for loop. It's just picking the character. And then writing to the buffer, and then it goes over the next one. So it picks, then it goes to the next. Then writes to the buffer and returns this. So these other functions, I have to study the library that he does it. These helper libraries here, I have to understand more how they work. And there's other ones on the other project as well. But probably what I'm gonna try to do is to just go over until I finish the course there again, and like get the functions from the course. Then once I get to the point, then I try to create something maybe, and only then I add the other files, because I think if I add the other files, there might be issues that are gonna stop me from being able to run the code, and then it's gonna take more time. But if I manage to run with the basic version first, then it is easier to understand. And then I add the other stuff once I get to the point. And obviously it's a lot easier than it would be because I have access to the course. So I obviously highly recommend. And it's very cheap as well, this one that I did. Just on Udemy, and he definitely deserves the money. It probably took him a long time to do all this stuff. There's a bunch of shitty courses on Udemy, but there's a few ones that are worth it, I think. Just freeze memory comes from C, but I have to research more. It's kind of hard to find videos that are gonna... Maybe not, maybe I already understand how it works. But I always want to understand on the low level of how the instructions actually work. And then it's harder to find videos about that. So... yeah, the thing that is hard is not the stuff itself, is understanding when to use each thing and how to use it. That's the part that is difficult, and I'm probably gonna struggle a lot in the beginning, because I understand everything here, but like when it gets time for me to do this stuff, it's gonna be very difficult to think about like what kind of thing you should be using it each time. Okay, so this returns the buffer pointer. These functions are just for quickly seeing if the string is the certain pattern. This is for operations, so it goes over the expression thing. That each part of the expression is going to be on an operator, and then creates based on the order of precedence of the language, which thing is going to come first to build the abstract syntax tree. Let me go back to the function. So I'm gonna go over this one first. So I think I'm gonna do it here. So inside of the switch, I add functions that after it creates the token, I have to see how. I think it's just assigning. No, I have to push. So I'm gonna probably create the vector, and then here I'm gonna have access to the vector. So I probably have to define on the compiler h file, and then I import there, or I don't need to import. I have to see which one is better to where define the things. But then I'll probably have the function here, nodes, or the vector that is gonna be the thing that is gonna contain the structure, and then appends. So I initialize the node with the token. Actually, the token is already the node. Or maybe not. I have to spend time thinking about it, because the node could be the token and the nodes of the tree. So the node of the graph contains both the token and the node of the tree. And that's the part that I'm gonna have to spend a bunch of time thinking about because it's gonna be the main thing that I'm gonna do. So just figuring out what is the best structure to get there, to extract the information from, to put on the visualization to make it easier to understand on the high level how it works. So I'm probably gonna do it here instead of each switch, and I pass the. Or actually, I can do it outside. So before the returns to the token here, that's a lot better. So I'm probably gonna do it there. And this is the thing, probably the main thing that I'm gonna change from language to language, because then it's gonna change the structure. But then I have to change everything else, I think. I'm still a little bit confused on. It's kind of hard for me to imagine now on how does the pointer work and how much information the buffer stores at each time. Because based on the way that he does here, it's like, how is it possible that you can define the things based on the switch case here? Because on the file you don't know, but I guess it's like just it's like you're putting a stream of data on this funnel that has this structure, and then it doesn't matter at like what is the order that you're putting them. But it's still kind of confusing because when you're writing code, it obviously gonna matter the order. So I guess this is the thing that I'm kind of confused about. But also you're always gonna read on the correct order probably because of the buffer of the file. So it's always reading from left to right, but it's still. I guess this is the reason why he says that the most difficult part is the precedence, the operator precedence thing, because it does matter which order it is. Yeah, that's probably the reason why. I guess the stuff that is confusing as well is the symbols, because yeah, the symbol case, which is related to the variables. That's probably the main thing that is gonna. Which is probably also related to the type conversion. And also the function scope. So it's both the symbols and the functions that I think is the hardest. So I'm gonna spend more time on them, I think. So I'm gonna copy everything, then go over the course. Then after I do that, I try to run that just from the way that it is now. After I run this, then I'm gonna spend more time looking at each thing that I'm kind of confused about and try to clarify in my mind. Once I get to the point, then I think it's time to create a graph, because then I'm gonna have a decent idea of what kind of information, because I already have like some things that I want to try first, because I think that they would be good to visualize on the graph. So I want to build the thing based on this stuff, having this in mind, but trying to not overcomplicate too much in the beginning. Yeah, so this is a symbol and not the thing, because it's the thing that closes, so it's not part of the expression. And the token create is also another main function, because it is the thing that creates the token. So just this one is also from C, which just copies one thing into the other, but I'm gonna review this as well. So it's copying the token into this temporary token and then assigns the position. This gets the position from the lax process. It's kind of confusing as well because this is a global variable, I think. Yeah, that's another thing that was one of the confusing things for me. Because these functions here don't accept the lax process, they call it so. Like this is a global variable, but then how does it work with the other stuff? Because the other stuff, when you create the lax process, it passes as an argument. So, okay, but probably the moment you declare is like on the other programming languages, when you import the file, it's gonna run the code, so it accesses this. But then how does this has the state of the process that is initialized on the functions? So like here. Because here is passing the process here and then creating the lax based on this. So, which is the other function there that is gonna initialize everything. So how does that function, how does that process has the same state of the other one? That makes sense. So this is one lax process and the other, and this is another one. So if you're initializing based on this, then how does the other one has access? It's probably, yeah, I don't understand, because this is the function that is running first. Oh, so here, yeah, that's the part. But I don't like this very much, to be honest. So the way that he made it work is just create a global variable here and then make all the other functions based on this one. And then here he assigns this global lax process, which is related to this file, to be equal to this one, which is the one that is initialized on here. But I don't like this very much, to be honest. So maybe I have to think about how to... The other way is obviously to always pass the lax process in all the other functions, but maybe that's not very good, and that's the reason why he did it like this. So I have to spend some time thinking about the trade-offs. Because then you would pass here and then all the other functions as well. I don't understand also what's the point of the type. So I have to think about how to search for this. Because in some situations he puts this type on the struct. And I'm assuming that is something probably similar to the way that like sometimes people put the underscore in Python in the variables to tell other people that they are private, even though Python doesn't have private things. So maybe it's one... it's kind of like that, where this is supposed to... It's not part of the language, but it's supposed to tell the person that this is a private variable or something like that. I'm not really sure. So cops gets the position. If it is an expression, does this stuff here. With the parentheses, that is part of the lax process. See what time it is. Damn, still 20 minutes. I think I'm gonna stop very soon. I'll be right back. So it has been a lot easier than I thought it would be, so I think I'm just gonna spend like 7 minutes or something like that more. And I'm just gonna spend some time talking to ChatGPT. And there is still a lot of other files here that I didn't copy, so there's probably gonna be more difficult things to understand. But I think it's better to probably watch the course before again, and also spend more time like really understanding these things here and these nuances here before I move on to the other stuff. So it's very clear to me how it works, and then I'll go to the other parts. It's probably gonna be hard when it's time to write, because then you have to think about when to use each thing, and the memory as well is gonna be difficult because I don't have experience. It's probably gonna take some time to build it. But maybe a lot easier than I was expecting to be. So I'm gonna ask ChatGPT how to save. I have to think about what is the best way to ask this. I wanna know if it is possible to save in a JSON in the same format that I would read in Python with the data structure already. Should probably have two different places. I'm gonna store after I finish copying everything and running, which I'm probably gonna do off stream. I have to just figure out, maybe after I get to the part of the course that he talks about the Linux file that is giving a warning here that is related to the path, but now it's not warning anymore, but I don't know why it's not. I just removed here as well. No, this is the one. Yeah, this file here. After I get to this point, then maybe I try to start running the Makefile. But it's probably best to save, after I have the whole project, just save the project somewhere else and then like have two copies. Then one copy I change to work with the graph. Then once I do that, then I go back to the other one. First I try to make the graph. I have to think about what is the best point to stop. Because obviously in the beginning I'm gonna do the simplest graph that I can, which is just gonna be the the tokens and the abstract syntax tree as it is with the execution. I think that's what I'm gonna do. So just at some points in the code, just put the extra logic that is gonna create the nodes and edges and save to a JSON file. So at that point, I have to think about whether or not it's better to try to think about different ways to create a graph, or to think about how to translate the compiler to work with JavaScript and Python. And I think that the answer is going to be, at least in the way that I'm thinking about, is how hard it's going to be to translate for the other languages, because it's going to be a lot better to make it work with JavaScript and C, because most people, JavaScript and Python, because most people know JavaScript and Python. So I believe it's probably better to spend time at that point trying to translate the compiler instead of trying to optimize the graph. But the issue with that is that I'm part of the build space team and there's 19 days. So like if I spend time focusing on translating, I'm not gonna have a lot of visualizations. So that's the trade-off. But I think that if I have like a simple graph in C, that's already good enough to have something to show, because then what I can do is just parse a bunch of C files. Like I can find C projects on GitHub and then parse. So this is another thing that I have to search for, is how to emulate the OS walk with. So I can go over the directory and look at all the files and then build the graph from all the files. And as long as I have a couple of them, I think is already good enough. But then it's probably better to spend time. And another thing that I might do as well is just to, because there's another series here that is very good, I'm gonna watch again. Because it is a lot easier to code in JavaScript and Python, so it might be worth it to just translate the C code to Python or JavaScript, and then from that point create the Python and JavaScript compiler or interpreter, and then from that point optimize the graph. That's probably the best, because it's gonna be most useful for Python and JavaScript. Then once I optimize the graph, then I can come back if I want to the C stuff and just try to incorporate the logic. So go back and forth between the two. So it uses the functions from the files, from the library itself. So it creates the graph already on JSON. Interesting. I was thinking more about creating the structs first and then calling some function on JSON to put the data. But if that works, then it's obviously going to be a lot easier. The other thing I can do is just put this code here on. Yeah, I'm probably gonna do this off stream. So I'm gonna save the code here. I'm gonna create another folder and then I just create another Makefile. So I'm gonna be good to like start learning more about how to structure things and get more comfortable with the module system. In the beginning kind of sucks because I have to get used to the way of thinking. But I think that after like this part, then it's gonna get a lot easier. So I have to run this to see what is gonna be the output and if it's gonna be the output that I want. But I'm gonna stop here and I'm gonna do this other stuff off stream. So probably gonna stream again on Friday, and I'm gonna continue to do this stuff here. So who knows how further ahead I'm gonna be until that point. But yeah, the plan is to do whatever I said I was gonna do today. So yeah, this is probably gonna come back on Friday.